All right, today we are going to start talking about radians. But before we get to radians, we need to understand some of the vocabulary that leads us up to radians. So we're going to start with degrees. And on your, did everybody get one? Everybody got the next? On here, we've got an XY axis, and we are going to have an angle that always begins horizontal. Is there somewhere else that the angles always begin horizontal? If we do this like last class, angle of elevation or angle of depression, those always start horizontal. So we've got like a theme going here. Angle of depression, angle of elevation, and now initial side of this angle will always start horizontal. It always starts on the positive x-axis, always. You see it right there on your picture? The initial side is the starting side of the angle. And from there, we rotate one of our arms, and that's going to form an angle. If I rotate my arm all the way around, what angle did I just form? 360 degrees. That's how many degrees are in one circle. If I angle my arms, it starts up, then it starts and it goes all the way to here. That's 180 degrees. Okay. What if I go to my initial side and I rotate to here? 90. What if I rotate halfway to 90? 45. Okay. But that angle that's being rotated, we're going to show with an arc and then a little arrow that shows which way it rotated. And then when we're done, this side is called the terminal side. That is the side that we stop at. Ooh, I got a really tricky one for you. If I start at my initial side and I rotate, not once around, twice around, 720 degrees. So we could go infinitely many times around and we could have any angle possible. If I start at my horizontal initial side, positive x-axis, and my arm goes down instead, it is now a negative angle. So if it goes up, it's a positive angle. If it goes down, it's a negative angle. And instead of saying up or down, we don't say that when we go around circles. What is it? What direction is it if we're going around the circle with this? That's counterclockwise. So counterclockwise are positives. But if we go clockwise, it's negative. It's like kind of opposite what you think, but that's how it is. So let's fill in the blanks. Standard position starts on the what? Positive x-axis. That's where we start. The initial side, always on the initial side, positive x-axis. This is the same thing. Terminal side, the ray that rotates positive angles rotates which direction? Counterclockwise. And negative angles rotate clockwise. And then there's two pictures for you. Example 1, we're going to draw an angle with a given measure in standard position. So we're going to start with an XY axis. Now I'm going to use different colors because I'm going to have to write on top of this, so I like to use different colors. It's totally up to you what you want to do. But I'm going to go and I'm going to draw my initial side, always positive x-axis, horizontal, always. This is my initial side. Now this is going to rotate clockwise because it's positive. If I rotate to here, I'm at 90 degrees. If I rotate to here, I'm at 180. If I rotate all the way down, how far have I gone? 270. But I only need to go to 240, so I'm going to go a little bit less than that. And I'm going to show anybody looking at this which direction I went with an arc and an arrow that shows which direction I went. So if somebody looked at my picture, they would know it was a positive angle. There's one more thing that I'm going to do on my picture, so that anybody who looks at my picture and doesn't see 240 degrees knows that it's 240 degrees. We're going to write something called a reference angle. Called a reference angle. A reference angle. That's going to be an angle that is formed by the terminal side and the x-axis. It loves the x-axis. It goes to the x-axis. It's formed by the terminal side and x-axis. So my picture up here, it's going to be that angle, kind of made in green. So I need to know what that angle measurement is. So if we went 180 degrees, and then we went a little bit past it, how far past 180 degrees was it to get to 240? 60. So my reference angle is 60 degrees. So even if I'm a bad drawer, somebody can look at this and go, well, they passed 180 and they went 60 more. It must be at 240. So 500, we're going to begin with an initial side. And then if I rotate all the way around, that's only 360. And if I go 90 more, that's 450. 500 more is going to be 50 degrees past a 90. To show that, you're going to show all the way around, and then we're going to swirl it a little bit further till you get to your terminal side. So I can see which way it rotated. I can see it went around more than once. Now, even if I'm a bad drawer, as long as I put in my reference angle, which goes to the x-axis only, everybody will know how far I meant to draw it. So how many degrees from 500 is it to get all the way to this 180? We went 360, 450, 50 more. How much is left? I need to do that again. Went all the way around, that's 360. Went to 90 here, that's 450. We went 50 degrees more. What's left in this quarter? 40, because these are all 90s. Each of this is 90s. Maybe I should have said that. So our reference angle is 40 degrees. Okay, that's to do. That reference angle is going to be very important. Okay, and then the next one is negative 50 degrees. So we start with our initial side. And then what's negative angle mean? We go clockwise. We're still going to go 50 degrees, we're just going clockwise. So it ends up down in the fourth quadrant. My reference angle is always positive. So how far is it from the x-axis? What is that angle? What, Jacob? 50. Yeah, 50. The negative 50 talks about when we rotated it, but the 50 degrees is what it actually measures. Questions on this? Does it matter what? It only connects to the x-axis. Did you drop to the y-axis on that one?
No.
Right. The reference angle is always to the x-axis. Always, always, always refers to the x-axis. When we go and do more stuff with reference angles, if you go to the wrong axis, you're going to get the wrong answer. Say, you got a question?
Yeah. I thought the reference angle was how much you have left in that.
It's how much to get to the x-axis. How much to go back to horizontal. So like everything's about the horizontal here.
Oh,
Okay. So sometimes we'll be past it, sometimes we'll be above it, sometimes we'll be over here above it, sometimes we'll be below it. It's just how much to get to horizontal. Okay. The next example, which one did you say?
Suppose we want 269.
Oh, you're making one up. 369 degrees. Yeah, because that's like almost 270, right? That's not drawn really to scale, but yeah, so I go all the way around, but the reference angle would be here at 89 degrees. That's exactly correct. And I wasn't going to do all these because of time. I just want to move on, unless you guys have more questions. Okay. Next is vocabulary of coterminal. Coterminal. You know what co means in English? Co with, like together. When we talk about collinear, we're talking about points that are on the same line. Coterminal would be the same terminal side. So if I started at my initial side of 0 degrees, and I went 360 degrees, or if I went 720 degrees, I would have the same terminal side. Those would be coterminal. Here with, there's two examples here. For example A, negative 45 degrees. If I go to negative 45 degrees, I will end up here. That's a reference of 45 degrees. But if you didn't see me draw that red arc, you didn't see negative 45, there could be infinitely many answers that actually end here. Can you give me a positive answer that ends at the same place that negative 45 ends? If I went clockwise, if I went around this side. 315 is correct. And I can get that mathematically as well. You just take negative 45 degrees and you add 360 to it. So at negative 45, we go all the way around 360 degrees. We are now at 315 degrees. So if you add a multiple of 360, you'll get a coterminal angle. So now I need another one, but it needs to be a negative coterminal angle. So if I have negative 45 degrees, and I want a negative coterminal angle, I want one that ends up here, but it's negative. How am I going to get that? I want it to end up in the same place, but I need it to have a negative answer, a negative angle. Okay, I'm going to demonstrate. I'm going to go negative all the way around, and negative 45 more. It's going to end up in the same place that just negative 45 ended up at. So how do I find that number? I'll take the negative 45 and a negative 360 combined to get negative 405. But those are not the only answers. I could just keep subtracting 360 and get more negatives and more negatives. Or keep adding 360. But you always add or subtract 360 for coterminal. So for part B, we are starting at 395 degrees. I need to find, where's that? That's right here. I need to find something that's coterminal with 395. I need a positive and a negative. We always add or subtract what number? 360, just all the way around. So if I add or subtract 360, give me an answer. $395 minus 360. Do it. Did you get a date? Can't hear you. 35, excellent. So is that my positive answer or my negative answer? Oh, that's a positive answer. So how am I going to get a negative answer? What now? Come on, don't give up. Let's go. What is it? What is it? You can't just make one of the negative. You got to add or subtract 360. What are you going to do to 395 to make it negative? Subtract 2 360s, right? 720. Take away 360, take away 360 more. Subtracting 720. What do you get? Negative 325. Good. Okay. And we don't need to do that. Add or subtract 360s. Okay, the next thing we're going to talk about is we're going to start talking about what a radian is. And we're not going to get very far into it. We're just going to learn what a radian is today. If you're struggling, stand up. While we're doing this, stand up. But it's a pretty important lesson right now. You know, like if I needed to convert inches to centimeters, there's like a number you can multiply by or divide by. I don't know what it is, but yeah, there is. Oh, yeah. Okay. If I wanted to convert inches to feet, you'd like multiply by something or divide by something. Like there's conversion factors. Radians and degrees are like inches and centimeters. They measure the exact same thing. They're similar in measurement. They just different measurements. Okay? And we use radians a lot in trigonometry. A lot. So we've got to understand what a radian is. So what I have, first of all, let's talk about circumference, because that's from geometry or even earlier than that. You guys should know what the circumference of a circle is. You should know that. Does anybody know the formula? Nope, pi r squared is the area. What's the other formula? That has a pi in it. And an r. It is 2 pi r. Good job, gold star. 2 pi r. So the circumference is 2 pi r. What is a circumference? What is that? Who's on the front? I did it out of order the way I did it last year just because of time. It's just like right at the bottom. What is a circumference when I talk about the circle? What is that? Like a perimeter? Yeah, totally. It is the perimeter of the circle. Exactly. It is the measurement all the way around. And if I wanted to know the measurement from like here to here, how much of the circumference would that be? A quarter. A fourth. Okay. So the circumference is 2 pi r. And why am I talking about that? Let's learn about what a radian is. I have a video. Oh, it's not that exciting though. It's actually kind of a slow video. I'm going to skate it out. It's just me talking. It's not my video. It's going to be me talking. Yeah, it's not mine. Okay, so what's happening right now is we took the length of the radius and they are raising it up to measure around the circle the length of one radius. When we take the length of a radius and we line it up with the circumference, the angle that is formed by the length of one radius, the ends of that radius, is called 1 radian. is the angle that is formed by taking the radius around the circle. So now what they're doing is they're sliding that radius slowly. It's actually on twice the speed. Wow. So now we've got the length of two radiuses, two radii, and then that's going to form an angle, a central angle. Really slowly. Just forming an angle, you see? Starting at the terminal side, it's going all the way over to the end of two radii, and that's going to be called 2 radians. You following? This is what a radian is. It's an angle that is formed when the arc length is a radius. So now I'm going to skip ahead a little bit. Come on, keep going. So 3 radii make what angle? Come on, 3 radii make what angle? 3 radians. You see how, though, it doesn't line up with 180 degrees? Not exactly. Almost, though. Guess how many radians? 1, 2, 3, and a decimal. Guess how many fit in half the circle? 3 points. 1, 4, 1, 5, 9, 2, 6. Pi. Okay, so now we're going to skip ahead. We're skipping ahead. Here's 4 radian, 5 radian, 6 radian. Guess how many radians? Here's 6 radians. Guess how many radians complete one time all the way around? 2 pi, or 6.28. Okay? So the circumference all the way around is 2 pi r, or 2 pi radii. Okay. So all the way around would be 2 pi measured in radians. The angle would be. So all the way around, starting at terminal side, going all the way around, that's going to be 2 pi radians. So halfway around is how many radians? 1 pi. Half of 2 pi. A quarter of the way, what would the angle be? What would that theta be if we went a quarter of the way around? Half pi, or pi over 2 is how we're going to say it, but yeah, half of pi. So that is how we're going to measure radians. Angles can be measured using either degrees or radians. There are how many degrees in a circle? 360 degrees in a circle. There are how many radians in a circle? Yeah. It's just a little out of order. Sorry. There are 2 pi radians in a circle. So 360 degrees is the same as 2 pi radians. 180 degrees is the same as pi radians. They are equal to each other. Just like 1 foot is the same as 12 inches. They are equivalent. Okay? So to convert between degrees and radians or radians degrees, we use 2 things that are equal. Pi radians is equal to 180 degrees. 180 degrees is equal to pi radians. When I put them on top of each other, the value of this fraction is 1. These are equal. So what I'm going to be doing is I'm going to be multiplying by values of 1 that just change the appearance, not the answer. When we convert this degree to radian, you're going to multiply by a value of 1. This is over 1. I'm going to multiply by a fraction. But with the fraction that I have to multiply has to have degrees on the bottom so that it cancels with degrees on top, just like we did that big chapter with canceling stuff. So the radians is going to be on top. So when I multiply straight across, my degrees cancel. The degree symbols cancel out. We get 120 pi over 180 radians. And then we will reduce this. We're not going to type in pi into the calculator because it gives us a horrible decimal. Just reduce this. So if we, what can we reduce 120 and 180 by? What divides out of 120 and 180? What factors out? Huh? I can't hear you. What factors out of 120 and 180? They both end in 0. What factors out? Oh, you guys are like way overachieving. What's like so easy to factors out? 10? Okay, so then I now have 12 pi over 18, but then some of you were telling me, oh, that's not the biggest thing that factors out, so what can I still factor out? 3, no, 6, 6. Well, I could not hear you saying this word. So 2 pi over 3 is the radian that is equivalent to 123. I think Owen might be finding that around there. So now, do you know if this is degrees or radian? I have a secret way of telling you. Ready for it? If there's a degree symbol, it's degrees. If there's no degree symbol, it's radian. It has nothing to do with the fact that there's a pi there. If there's a degree symbol, it's degrees. If there's no degree symbol, it's radians. So if you go and you look over your other work and you see 180 sitting anywhere on your work where you didn't put a degree symbol, then I would like mark that wrong. If you're trying to say degrees and you don't put a degree symbol, I don't know. I didn't look at it earlier. So like right here where you have 45, to me that says 45 radians. Take away 360 degrees. You see what I'm saying? So if you don't put the degree symbol, I think it's radians and I mark it wrong. Just so you know. Okay. So how we can tell that this is in radian form is that there's no degree symbol. So I need to convert it to degrees. I'm going to multiply by something that has radians on the bottom and has degrees on top. So 180 is equal to pi. But I know that the radians go on the bottom, so that pi radians cancels with pi radians. We multiply straight across, you get negative 180 degrees over 12. And then you divide those, and you get negative 15 degrees. So there's your conversions. I would not give you those conversions on a quiz or a test. So it'll be something that you do, and then you learn how to do it. This one's easy to remember because you want the degrees to cancel out, so the degrees have to be on the bottom. This one, if you want it to end in degrees, degrees stay on top. All right, last section is evaluating a trigonometric function using your calculator. Ooh, it's your calculator. Oh. You know, it's on there. Isn't it right above the chart? Okay. It's just not, it's not up and down because I couldn't fit it. Yeah, I couldn't fit it on the page that way. Okay. So, how do we evaluate cosine of pi over 9? How? What? Jacob, if you could just like speak a tiny bit longer. So, when I was younger, and I had cancer, and I had chemotherapy and radiation, it did mess with my ears a little bit, and sometimes I had trouble.
Should we keep our calculators on degree or switch to radian?
That's an excellent question. Is this a degree or is this a radian? How do you know it's not degree? No degree symbol. So then the first thing you have to do is go to your mode on your calculator. Everybody do it. Go to mode. change your mode to radian. You don't change your mode to radian, you will get the wrong answer. Now, type in cosine and use the pi button. The pi button is like second caret.
So we're going to use the pilot.
No, we never use it anymore. We always use pi. I was talking about when you were looking up that radian where it has it like saying that it was 3.141591 or 2.
What? I know. You said it like.
Pretty cool. Okay, let's see if you got the correct answer to 4 decimals. I know you all just typed it in, but do it quickly. You should get 0.9397. Did you change your mode?
Yeah. Oh, what's the back?
That's a degree. Maybe you forgot to hit like enter. Alright, tangents for pi over 5. Try it. We're showing all 4 of these. Make sure you know how to put in your calculator correctly and get the right answer. I'm going to go put the answers up. I was just helping him out. He had D correct. That's not right. Come on, anyone. Negative 0.7265. You have D correct? All right, C. How do you type cosecant?
1 divided by sine.
1 divided by sine. Where's the angle go? With the sign down at the bottom. 7 pi over 6. Now, please type this in so you can make sure you're typing it in correctly. It actually equals an exact answer of -2. Typed it in correctly. You typed it in. Remember, cosecant goes with regular sine. Cosine goes with secant. There's only one co per couple. And then how about sine? Ooh, is this degrees or radians? There's no degree symbol, so answer my question. Is it degrees or radians? This is radians. Just because there's a number and no pi doesn't mean anything. It's no degree symbol. This is radians. You type it in, it should be 1. You type it in. Okay? It should be a good, easy homework assignment. It is in the book. And we've got to start memorizing those values. I'm going to stop the video, so if you're getting a picture of that, I'm stopping the video.